In networking, there's a lot of technologies that can be utilized at layer 2. One of those technologies we know and we rejoice about is Ethernet. Is there addressing that Ethernet utilizes? We know there is, and it's a MAC address. Let's focus on these MAC addresses in this particular nugget, as well as introducing you to layer 2.5 addressing. And I'm going to just leave that right there and pique your interest in, my goodness, what we didn't discuss a layer 2.5 when we discussed our OSI model. More on that in this particular nugget. So if we have Ethernet interfaces on one of our Juniper devices, it seems to me that we should be able to see the MAC address of that Ethernet interface. Let's check that out. So here we are on a Juniper router, and I'll do show interface, and we have some gigabit Ethernet interfaces on this device. I'll go ahead and look at one of those, and if we look at this output, we can see a current address field here. And sure enough, here is the MAC address that is assigned to this particular interface. Now, wait a minute here. It says current address, and then it says hardware address. See, what happens is the manufacturer, in this case Juniper, of this particular device burns in. We call this the BIA, or the burned in address. They will burn in a MAC address. And sure enough, it is this hardware address right here. The fact that there's this current address field indicates that you can change it in software, but this is a rare configuration that we would make. So commonly we see this, that the burned in hardware MAC address, the 48 bits, is indeed the current address for this particular device. Notice the 48 bits are represented in hexadecimal. And on a Juniper router, they do one hex digit, then a next hex digit, then a colon. So they do 6 groupings of 2 hex digits with colons separating them. Please be aware that we do see variation in this presentation. So if I fire up my Windows command prompt, for instance, and I say ipconfig/all, and we look at the MAC address on the interface on my Windows machine, let's look right here, our Ethernet adapter. We can see there's the physical address of this particular NIC inside my Windows box. And notice the presentation is slightly different. It's dashes in between those hex digits instead of colons. You might see it just the string of hex digits with no delineation in groupings at all. So be ready to be flexible when it comes to recognizing the MAC or hardware address of your device. So no matter how they're presented, we absolutely love our layer 2 MAC addresses. You know who really loves them? Yeah, remember layer 2 switches. Layer 2 switches are in the business of memorizing these MAC addresses and specifically out which port the MAC addresses live. They memorize the locations of these MAC addresses so they can intelligently forward frames to the appropriate device, unlike those silly hubs that we have discussed that simply repeat the bits out all of the ports and do no memorization of the MAC addresses. Now, did you ever lay awake at night worried about this? MAC address conflicts. I mean, think about it. Every MAC address has to be unique on our network in order for things to be happy. Well, this is handled a really, really clever way. So here is our 48-bit MAC address, and notice the first 3 bytes are what are called the OUI, or Organizationally Unique Identifier portion. And if you look at the first 8 bits of the MAC, you discover that this bit right here and this bit right here have very specific and important meaning. Let's take this one first, B1. This indicates whether the MAC address is for unicast or multicast traffic. Remember, unicast traffic is when a device is sending traffic directly to a single other device on the network. Multicast traffic is when a device is sending traffic to a group of devices that want to receive that traffic. This is really like almost like a subscribing to a television station type of analogy. It's an efficient way for one machine to send information to many machines. It's more efficient than a broadcast because in a broadcast, we send it to absolutely everyone on a segment, whether or not they've indicated any interest in that information. So multicasting is super cool. Notice if there is a 1 in that specific bit position, then we are indeed dealing with multicast MAC addressing. Notice B2 in these first 8 bits, though, indicates whether this is a globally unique address or one that's completely locally administered. So if you wanted to, you could go in and you could set your own locally administered MAC addresses on everything. What is more common, of course, is we have our globally unique MAC address. Cisco has their prefixes, their 8-bit positions that are assigned to them that they can utilize. Notice they then set the network interface controller specific portion so that there's no conflicts. So big network vendors get their MAC address space, and then within their MAC address space, they manipulate those 3 bytes to make sure the addressing is unique amongst the devices that they are creating. Pretty cool. But wait a minute here, I've got a little bit of a problem with all of this. If we have a system and this system wants to communicate with, let's say, a Juniper router that is indeed running on our particular network, and they're connected via our Ethernet LAN, one of the things that I'm troubled with is the fact that at layer 3, we utilize IP addressing. We know that, sure. And we're talking about layer 2 MAC addressing right now. It seems to me that we need to be able to resolve these two things. In other words, when this machine is looking for this Juniper router and wants to talk to it utilizing IP addressing, we know first, though, at layer 2 in this Ethernet world, the MAC addressing must be learned so they can properly communicate. The glue that binds these addresses together, or more properly stated, the resolving technology is ARP, the Address Resolution Protocol. Let's prove right now that ARP is being utilized on an Ethernet network. What I'll do is I'll go to my Windows machine here and I will reach out via IP address to my default gateway. That's at 192.168.1.1. So I'll ping my default gateway. And sure enough, the default gateway replies. Very quickly, by the way, because I'm sitting right next to that default gateway. Really good connectivity here in my home office. Okay, great. So we have now reached that device by IP, but did ARP in the background find the MAC address for the device at 192.168.1.1? Let's see. If I do an ARP-A listing all of the information that's known in the ARP table or ARP cache on this device, if we scroll up, we should indeed see that, yes, 192.168.1.1 was indeed resolved using ARP dynamically. And this information will stay in this table for a nice period of time so that each time we try and communicate with this internet address, we don't have to do an ARP for the physical address. We've got this information in the cache. Remember, ARP is a broadcast-based technology, and we tend to think that broadcasts suck. As a matter of fact, we'll learn together that in the next generation of IP, IPv6, broadcasting is completely done away with. No broadcasts in an IPv6 world. As you might guess, it's multicast traffic that replaces that functionality. So the layer 2 switch makes its money with MAC addresses. The router certainly utilizes MAC addressing and understands MAC addressing, but what its primary concern is of course the IP addressing, the layer 3 forwarding of traffic from one segment to another segment in our network, maybe even out to the public internet. So IP addressing at layer 3, MAC addressing at layer 2. What about layer 2.5 addressing? What's happening here? One day, some really clever engineer woke up and said, you know, I'm going to create my own addressing. I am going to create an address simply called a label. And I am going to forward traffic based on that label. This is layer 2.5 addressing, otherwise known as multi-protocol label switching. MPLS allows the movement of traffic based on label assignments. Technically, our routers become what are called label switch routers, or LSRs, and they go ahead and forward based on what's called an LSP, a label switch path. Now, you might say, what's the big deal? I mean, why not just forward by IP address? Well, what's cool is the label switch path information can be, first of all, it's unidirectional through your environment, and it can be independent of the routing, the forwarding table. So we have the ability to engineer traffic flows through our network very flexible using labels. We could say, hey, for whatever reason, we want some of these packets to go one way and some of these other packets to go another way. Even if you decide to forward based on MPLS labels and you want to follow the routing table path, you still have some beautiful efficiencies when it comes to using labels. What happens is the label table, if you will, is so much more efficiently used by the routers. Now, for brevity's sake, I have definitely simplified the discussion and the joys of MPLS. As a homework assignment, and this is optional, it really is, but I would really encourage you to go to my blog, AJS Networking, and do a search on MPLS. There is an article I would love for you to read called Why the Fuss About MPLS, and it will go into much more detail about why this layer 2.5 addressing was created and just how remarkably it can solve some major problems that we were having with networking. So the mystery of layer 2.5 addressing is revealed. It's MPLS technology, one of the very, very interesting areas that you can specialize in today when it comes to routing and switching. Layer 2 addressing that we looked at in this particular nugget, of course, was all about the MAC address. And remember, there are other types of layer 2 addressing. For instance, maybe you're running still in your environment an older WAN technology called Frame Relay. The layer 2 addressing that we use in Frame Relay is called DLCs, or Data Link Connection Identifiers. So plenty of examples of layer 2 addresses out there. It's just we become in this course rather obsessed with Ethernet and MAC addresses, and we'll have more to say about that in other places of the course. I sure hope this particular nugget was informative for you, and I'd like to thank you for viewing.